Hello guys, welcome to Numerical Point, and this is our ongoing lecture series on fluid mechanics. And first we are dealing with fluid properties. Okay, so first we have discussed viscosity. Now we are discussing about surface tension, and from today onwards we are going to start a new initiative, that is one question daily. Okay, from today we are going to post one question, and by the help of that question we are going to discuss all about the concepts, all theories. And before we just start, please subscribe to our channel for the latest updates. So why wait, let's get started. So guys, let's start with today's question. The question reads like a solid cylindrical needle of density 7800 kg per meter cube may float in water surface at 20 degrees Celsius having surface tension of 0.073. Neglecting buoyancy, the maximum diameter of the needle able to float on the surface is dash. So guys, the question has given the density, that is 7800 kg per meter cube, and the surface tension is given at 20 degrees Celsius, that is 0.073. So here I want to say one point, that surface tension is a depends on temperature. Okay, as temperature increases, the value of surface tension decreases. So in order to define the surface tension, you need to first give the temperature. Okay, at 20 degrees Celsius the surface tension value is this. If temperature is increased, then the value will decrease. If temperature is further decreased, then the value will increase. So let's first try the data that is given in the question. In the question, the density is given 7800 kg per meter cube and surface tension is given 0.073 Newton per meter. So the diameter of the needle is asked. Okay, so now let's see how the pictorial version of the question, how the actually the scenario looks like. Okay guys, let's suppose this is the water surface. Okay, this is the water surface, this is the boundary, and this is the needle. Okay, this is the needle on the top of the water surface. Okay, so there are two types of forces that acts on the needle. One is the surface tension force and other the weight of the needle. Okay, now we need to say one thing. If the needle is in equilibrium, then both of the forces will balance each other. So we can write Fs, that is surface tension force, will be equal to weight of the needle. Okay, so now let's see in the picture what are the direction of the surface tension force. Okay, so guys, this is the direction of the surface tension force. Okay, as I have said, the surface tension force acts perpendicular to the body and in the plane of the liquid surface. So this is the direction, and the magnitude of the surface tension force will be sigma into the perimeter. Okay, sigma into the perimeter. But here you can see, let's suppose this is the length of the needle is L and diameter of the needle is D. Okay, let's suppose length is L and diameter is D. As the needle is very thin, you can say L is very larger than D. Okay, so we can neglect D in the calculation of the perimeter. Okay, so in the calculation of perimeter there will be 2L. One is this side of the needle, the right side of the needle, and other is the left side of the needle. So the perimeter we can write, it is 2L. Okay, it is 2L. And what will be the weight of the needle? Weight of the needle will be mass into G. Okay, what you can write with for mass? Mass is density into volume into G. Okay, so volume you can write rho into area of the surface into length. So we can write pi by 4 d square. This is the area of the cross section into length is L into G, which is equal to sigma into 2L. Okay, so if we'll see in both sides, L and L will be get cancelled out. So what remains in the equation we can write, if we'll take everything to the left and keep the D in the right hand side, so we will have 4 into 2 8 into sigma rho into pi. Okay, rho pi into G will be in the denominator equal to D square. Okay, to remove the square term we need to take the root over. Okay, so D will be root over of this term. So in the question it has given, okay, in the question what are the data are given. Here we can see the density, that is rho, is given. Surface tension means sigma is given. Okay, rho is given and sigma is given in the question. So rho is given, sigma is given, so G is 9.81. So let's put all the values. We have put all the values. Now let's calculate and find the value of D. Okay, so by calculating this we can find the value of D is 0.00155 meter. Okay, which can also be written 1.55 mm. So this is the answer of today's question. Okay, so guys, I think you have enjoyed the today's question, and we'll bring more exciting question in the upcoming lecture. So for that you just subscribe and never miss any update. Let's meet in the next class.